Today we're going to talk about frequency and histograms, how we can use frequencies to make histograms. Now, a frequency is just a count of how often something happens. A histogram is basically just a bar chart that is showing exactly how often something happened. Now, the difference between a histogram and perhaps any other old bar chart is a histogram specifically references the use of a frequency. A histogram is not going to show you a percentage. A histogram is going to show you the exact number of times that something happened. Okay, so let's start off with this problem. The numbers of home runs by the batters in a local home run derby are listed below. What is a frequency table that represents the data? To begin with, first thing we want to know is what is the minimum? As we look through those numbers, the minimum is 2. The maximum will be 17. So that means our data ranges from 2 to 17. Now, notice this next statement. It's kind of weird. It's saying that there are a total of 16 possible values between 2 and 17. Now, normally we'd be inclined to say, no, from 2 to 17, that's 15. All we're doing right here is talking about the total quantity of numbers that exist. So I want you to use your fingers for just a second, and we're going to count how many numbers there are from 2 to 17. So each time I say a number, you should hold up another finger. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at 11, it now looks like I've got 10 fingers up. So now start them over. 12, 13, 14, 15, 16, 17. So now I've got 6 more. So in order to get all the way from 2 to 17, there's a total of 16 different numbers, starting with a 2, going to 17, that are in there. Now, in our frequency table, we're going to want to take account of every single one of those possibilities. Now, next we're going to choose the interval. The interval is basically just the grouping. Now, the person who batted 2 and the person who batted 3, they're probably the same kind of quality of player. And so we are just going to group them together inside of one single group. Now, maybe that one's easy, but how big do we make these groups? And where do we finally draw that line between this is now a new group? Generally, you're going to want to choose between 4 to 8 intervals. Now, to make your life easier today, I would stick to around 4 or 5. Okay. Now, that means we're going to be creating 4 groups. Now, if I've got 16 total possible values and 4 groups that I want to make out of those numbers, that means each of my groups are going to have 4 numbers in it. All right, so this is our next step. Here's the reason why we found the min and the max. We found the min and the max to figure out how many possible values. We now take our possible values, which is 16, divide it by how many groups you want to make, in this case 4, and we've got a size of 4. Now we're going to make a table. This table is going to be the frequency table we've been trying to get. In your first column, we're going to start listing the intervals. Now, my smallest number was 2, and we want it to be the size of 4. So once again, using your fingers, just count it off with me. 2, 3, 4, 5. So that was 4 numbers right there to go from 2 to 5. All right, so now we'll have to start at 6, and once again, we're going to count off 4 numbers on our hands. 6, 7, 8, 9. Okay, and now we're going to have to start at 10, 10, 11, 12, 13, 14, 15, 16, 17. All right, so now we've got all of our intervals. These are our groupings. We're going to put all the batters who did between 2 and 5 together, all the batters who did between 6 and 9 together, 10 to 13. Now, your second column is your frequency column. There, you're going to mark how many times something happened. So for the 2 to 5, we're just going to count how many times we see a batter that got any number between 2 and 5. So there's 1, 2, 3, 4. So we've got 4 there. Now for the 6 to 9. So 1, 2, 3, 4. So 4 there as well. 10 to 13, you just go through your list. Once again, look for anything between 10 and 13. 1, 2, 3. 3 there. And now 14 to 17. 1, 2, 3. And we had 3 batters there. Okay, so here's a question for you. This is the exact same data. All right, now what you're supposed to do is answer this question. What is the frequency table if the intervals are of the size of 5? So now we're changing the interval to size 5 rather than size 4 like we did last time. All right, now, one thing I notice about A is how many numbers are in that interval. So count them off on your hand. 2, 3, 4, 5, 6, 7. That was 6 total numbers. All right, now with B, they did it correctly. 2, 3, 4, 5, 6. And that was 5 numbers. So they had got the correct size. And we'll notice that between B and C, all those sizes are exactly the same. So both B and C have the right intervals. So now we got to figure out which one has the right frequencies. So let's look at one where they disagree. Right there, between 7 and 11. B says there's 4, C says there are 5. So let's go ahead and count all the ones that go from 7 to 11. So there's 1, 2, 3, 4, 5. So the answer must be C. It counted the proper frequency for 7 to 11. Right, now making a histogram. The data below are the numbers of hours per week that a group of students spent watching television. We want to create a histogram that's going to represent this data. To make a histogram, first we need to create a frequency table. All right, now this goes back to a lot of the stuff we just did. First, we figure out the min and the max. That's 0 to 22, which means we've got a total of 23 possible values. All right, well, we're used to that. Even though it looks kind of weird, one thing you will always notice is that when we're figuring out how many possible values, the possible values is always one more than what the range kind of looks like. So 0 to 22, we'd normally assume 22, but in this case, just one more. And then you've got the total possible values. We want to create about 4 intervals. Now 23 doesn't divide into 4 perfectly. We get 5.75. It would be a bit of a hassle for us to do decimals on every single interval, so we're just going to round it up to approximately the size of 6. All right, so now we know we're going to start at 0. We want it to be of size 6. So I'm just going to count off on my hand till I get 6 numbers. 0, 1, 2, 3, 4, 5. There it is. 6, 7, 8, 9, 10, 11. 12 through 17. 18 through 23. All right, now the frequency. Once again, you're just going to go through and count them off. I would even recommend crossing them off as you count them off. Okay, so 0 to 5, we're going to have 6. 6 to 11, we'll have 5. 12 to 17, there were 3 students who watched that amount of television, and 18 to 23 hours in a full week, so only 1 student who did that. Okay, so now in making the histogram. Now, I said a histogram is like a bar chart that is just counting the frequencies. Across the bottom, across your x-axis, you're going to start putting in all of your intervals. The intervals are the groupings. So 0 to 5, 6 to 11, 12 to 17, 18 to 23. On the left, we're going to put the frequencies. So our biggest frequency was 6. And so I'm just going to go from 0 to 6 and counting by 2s. Now from 0 to 5, we went as high as a 6. So I have a bar coming out of the 0 to 5 going as high as 6. From 6 to 11, we add 5. From 12 to 17, 3. And 18 to 23, 1. That's a histogram, just a bar chart showing how often we saw that number within that particular group of numbers. Okay? All right, so here's your next question. The finishing times in seconds for a race are shown below. What is a histogram that represents the data? Okay? So, one thing you should notice in C, it goes from 70 to 79. There are no numbers in the 70s, so C is right out. In A, 87 to 93, we only had 3 numbers here that were between 87 and 93, so A is out. B is the only one that correctly identified the correct frequencies for each of those ranges. All right, now we're going to talk about the shape of a histogram. Different shapes have different names. So, first one we're going to talk about is symmetric. This is one of the most common that you're going to see when analyzing data. The peak is going to be in about the center and the sides will be roughly equal. Now, you should be drawing these histograms into your notes. You don't need to get all these exact numbers or make it look exactly like these, but get the rough shape. Now you'll notice in this one, yes, the peak was dead center, and each of the sides were, well, exactly the same heights as each other. This is perfect symmetry. Now in the real world, perfect symmetry rarely happens, but that doesn't mean we're never going to see symmetry. If it's roughly symmetric, then we will still call it symmetric. So we do still have the peak here in the center, and the sides were about the same height. So yes, I'm going to call that symmetric. Once again, it looks like our peak is in the center, sides roughly equal, and therefore I'm going to call this symmetric. Skewed. Skewed is talking about the data being skewed off to one side. So if I were to place all of this on top of a balance, and I put the balance right there in the middle, this thing's going to tip over. It's going to fall over because most of our values are over here on the right. Now this is actually considered left skewed. Okay, call it what's skewed as for where your tail is. So we see it tailing off over here on the left. Now over here on the left, we've got our peak is on the left, so our tail is on the right. So this one is going to be right skewed. Uniform. Uniform, the data is relatively evenly distributed. So this first one, this is perfect uniform. Okay, every single group has the exact same number. Now, in this next one, they're not quite as perfect, but we do see everything's at about the same number. They're really close. So I would still call that uniform data. I didn't really see any peaks there. All right, now, here's another set of numbers. You guys should make a histogram of the data and then answer, is this histogram uniform, symmetric, or skewed? Here's the first histogram I made of it. Now, I would say that almost looked uniform to me. Everything approximately the same height. Perhaps I would call that skewed because we do seem to have more numbers on the left than we have on the right. And our right was the smaller side, so I'd call that right skewed. However, using these exact same numbers but changing my interval, I've now suddenly got something that looks symmetric. We got that perfect peak in the middle, two sides are equal, and so we've got perfect symmetry on that one. And then change those intervals again, just a little bit, and now it almost looks like we've got our peak over here on the left, so a tail on the right, so then once again calling that right skewed. Now, one thing you'll notice um, with these is the intervals will make a big difference. Now, I think the symmetric one is probably the one that best represented the data. Our uniform, it went all the way as high as 21 inside of its final interval, but you'll notice none of our numbers is really even close to 21. So of course that particular grouping is going to be small. Whereas in our next grouping over here, we do see that it ended at 19. Well, that's much closer to the max that we actually had. Okay, and the same with our final answer C, but even then, our groupings were a bit small. All right, now a cumulative frequency table. A cumulative frequency table tells you the number of data values that are less than or equal to the upper limit of each interval. We'll see what that means in just a second. It's really not that hard. The number of text messages sent on one day by different students are shown below. What is the cumulative frequency table that represents the data? So there's all our numbers. Don't worry, I'm going to help you do a lot of the work. The max is at 49, min is at 0. You can divide this data into 5 intervals. Remember, because 0 to 49, we're going to have 50 total possible values. I'm going to divide it into 5. So each one of group of number 10. So 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 through 49, each with 10 numbers inside. Frequencies are 11, 3, 3, 2, and 2. Now your cumulative frequency is going to represent everyone that is at that amount or below it. So 0 to 9, there were only 11 people who were between 0 to 9 and below. Now you'll notice for 10 to 19, we're up to 14 because we have the 3 from the 10 to 19 plus the 11 from 0 to 9, the ones who are below. So the next one, 17. Okay, because we've got the 14 that were from 10 to 19 plus an additional 3 from the 20 to 29. So then 19, because we've added in a 2, and then 21. We've added in that final 2. Your final cumulative frequency should represent everybody. It should include all of your numbers. So I do have 29 numbers that are or 21 numbers that are listed there, and that's my final cumulative frequency. It is saying that everyone did 49 texts or less. All right, so figure out which cumulative frequency table accurately represents the data below. All right, so one thing I'm noticing is each of these has the same interval, so there's not going to be any problems with intervals. I do see that we've got some discrepancies in how they counted off some of these. So let's go ahead and just check the 5 through 9 section. So 1, 2, 3, 4. All right, so we should have 4. Did I miss any? Nope. And so there we go. We figured out it can't be either of those because they did not accurately count how many were there. One thing you'll notice, we started with 6, then we added the 4 to get